Hello, this is ABC and welcome to Data Engineering and Infrastructure Community. Our today's topic is
Topic of interest was streaming. How is the streaming ecosystem now looks like? What are the entry point? What kind of complexities you rise? And what are the recommendations? And the second topic is notebook and then deployment. Like how is the ecosystem kickstart with? So we will take the first streaming ecosystem, and who would like to start? One, two, three. I will
Uh,
randomly select. Okay, Hitesh, do you want to go ahead?
okay. Uh, so, Amy second system for the time, for quite some time, the Kafka has been the leader in the game. I would say from around 2016 or even before that. So, I have been using Kafka since 2016. So that's why I can say that pretty, pretty good in terms of what you want to do. If you have your capacity management done. So in Kafka, one of the most uh, difficult thing to do is capacity management. Uh, that's where the most of the time goes in, and then writing the code and integration with other APIs is pretty simple. So I have not worked much with the case team or the case equal which is introduced later, but I've worked uh, basically I worked with Kafka as your messaging bus because they are distributed messaging bus, uh, or you can say a steam engine. And we were using either of Flink or Spark to process it. So, so right now the streaming ecosystem is changing quite a bit. With respect to how, since most of the companies what they are doing is they are moving towards the cloud native thing. So that's why you'll see the advent of Event Hub or Kinesis, uh, and they are coming into picture more than earlier. And then there is a stream aggregator sort of stuff from the Pulsar, which basically has you could say support for multiple streaming formats, and you can use Kafka with Pulsar. So that's what the current ecosystem of streaming looks like, I think. This might not be a detailed account of what we have right now, but this is what I am aware of.
Cool. Thanks. Anyone else wants to share on the streaming anything?
I think one thing I've seen about kinesis is, and this is from an old experience, so it's kind of little old, but yeah, from kinesis I've seen is the advantage of syncing it with S3. It's like at least I remember Kafka didn't have a direct connector with S3. I'm not sure if things have changed. I know there's this Kafka Connect which you can configure and stuff, but that also supports some specific file formats if I'm not wrong. So essentially for warehousing or anything like that, right? Like creating your data lake, and rather than going through hoops where you store first, you connect it to a different database or something, and then flush it down to S3. Kinesis had a better support for direct S3 connect, which is where I saw the advantage. In terms of cost, I've heard Kinesis can be more expensive than Kafka, but that would be a different discussion, I think, because then it's like you're managing your own Kafka services, what problems you face, how many times do you have to update it versus Kinesis being more managed service.
Okay.
So the problem of not having backup. So basically, the Kinesis, the data going into S3 is basically a different service, which is the Kinesis Pyro. So Kinesis Pyro, basically what it does, it basically collects chunks of data for 15 minutes, up to 15 minutes, and then dumps into the S3. And that's what you get. So basically, you can store your message as it is, or you can pre-process them using Lambda. And as everyone knows, when you want to pre-process something using the Lambda, it's per invocation call. And suppose you have the frequency like uh, any frequency. Let's suppose you're dealing with sensor data and you have frequency of 10 kHz for one sensor. And when you try to use that sort of frequency, the cost goes like when you try to pre-process, then the things get really expensive. That's where Kafka is relatively inexpensive, because what you can do is you can have this using casing, you can have the Kafka topic to topic pre-processing, and then from the topic you can have the Kafka connector. And as of today, I think even there is a connector being written for the Kafka for Delta Lake, and I'm not aware of the iceberg right now. Is there a connector or not? But for Delta Lake, I have definitely seen the development going on. So that's one thing. And also, one thing I forgot to highlight earlier was, with the advent of the open streaming formats, like, sorry, the open table formats like iceberg or Delta Lake. Some of the use cases of the streaming, because people were going with the file streams and they used to store the data, and they used to pass on the data as a stream to the Kafka stream, and then there were multiple streams which is working. So that is being replaced right now with the open table format, since all three of the major open table formats, Iceberg, Foodie, and Delta Lake, support the streaming dataset. So that's why they are being used as a replacement in many of the systems.
Cool. Thanks. So there are two things. First and very first, so I will zoom back a bit, just for whoever see the video on the offline mode to understand how we started with this point. First, why even streaming? That question comes to the picture. That there is a batch and then there is a streaming. Usually we have a small chunk of events data which come over a time. It is an infrequent. It is get over a frequency. It is always getting updated. So initially we started with micro batching, not micro, 5 minute, 10-minute window batching, so that in 10 minutes the new data comes and you do it. But eventually the requirement changed and it's being said, I want a real-time update on my dashboard, just for example. So you are seeing something is updating, like a stock trading, which by the way was only limited to stock trading one point of time, and now it's like seems like every business needs something in the real time. I don't know it is a real use case or not, but yes, that's what the main argument on. We need a real-time preview of whatever the event coming and to see. Another use case is where it is a real use case in infrastructure and logging and metrics. That is real time. So real time they need to alert me if some anomaly is there. Over real time it need to alert me if I'm putting the cost high, if some CPUs are burning way too much memory, if some GCs are crashing. So those are our real time events where I really see something happening. And then bidding, the ad bidding in window, where in real time you change the ad based on the scenario, weather and terms and condition of the user. So yes, there are use cases where you need to real time react to a particular events coming to a system. It can be a user profile, it can be anything. And when this kind of things happen, when you want to actually work on a real-time ecosystem, that's where you need streaming engine. In a streaming engine, usually what happens is you keep on getting the data in the system, and you can't save it to S3. Yes, you can, but by the way, if you put the thing in the S3, what happens is you need to go, and from S3 you need to read the data. It's a latency. So first you will write, that is slow, then you will read, then again it's slow, and these are all stored. So it is a persisted memory. It's a blob stored, so everything is persisted, slow. It can be SSD, it can be hard, it doesn't matter, it's just slow. So that's where the first problem came, that why do you even want to persist the data in an immutable state? Why not keep it in the memory and you read it faster? And that's where you need all this queue engine came up. First you need queue engine. The queue engine can be anything. It can be Redis, it can be memqueue, it can be many. And then comes Kafka, the behemoth. Kafka, I must say, it's a huge it's a big framework. It is not a very tiny framework. So if you are testing and trying, or you are not sure what kind of load you are talking about, Kafka is a bit expensive in the terms of management, not the cost. It's open source, so everybody can say, yeah, it is good, but it's a bit a heavy tool, but it doesn't mean you should not use it. I'm just saying, yeah, it's heavy tool. And then AWS recommends Kinesis. There's a pros and cons, and Foundation, I just don't want to go there. But in Kafka, you need to understand the concept of partitions, that what the hell is partitions, which is nothing but scalability, how to scale, how to parallelly read those events, how many consumer can do those things is based on partition. So this is one logic you can read and go through it. And the next thing you go over there in Kafka is topics, which in Kinesis I think shards, if I'm not wrong, or something they,
So in Kinesis, you have the theme, you basically have a theme name, and then your shards are basically your party.
yeah, okay, shards are the partition. Okay, yes, shards. So shards are anyway the database partition from older age, so that is what they put it.
What happened with respect to this theme actually at the time? So whatever, so basically in-memory system, okay, in-memory system. So in the stock market analysis, so let's suppose to get to know about how certain stock is doing, or let's suppose uh, there is a regularly sorry, like in India, so you're trading on NSE, and there is a regulatory authority known as SEBI, and SEBI gets a tip from someone that so there is an insider trading going on, okay, and they want to look into that data in real time so that they can be caught, or that can be stopped. So they have their systems. So these things need to be done in real time, because if they are not done in real time, that means the price manipulation happen, and the innocent investors, most probably the retail investors, will lose their money, uh, or something, other things can happen. Sometimes even the companies can go bankrupt. It has happened in the past. So normally what happens is they have their this is what the architecture NS is right now. So basically whatever data that they are getting in, so they have data coming in from their trading system, the original trading system which was written in C. From there, they are getting the data into Kafka, and then from the Kafka, there are multiple streams going into the multiple consumers, and for the analysis of that data with respect to uh, also there is one more thing called as a the brokers. The Since whatever you want to buy, you cannot buy directly. Okay. So the brokers are responsible for whatever you buy or sell. So basically, what is the liability of broker? Uh, how many shares does the broker have? And at the end of the day, that has also be settled. That has also to be settled. So all the stuff, for all the stuff you need the storage, which can work in real time, and that's why the frameworks like Druid and Ignite also came into picture. So they are basically like the in-memory engines. So basically, whatever data that you have. Uh, so uh, so normally what happens? So on the same machine you have Kafka. The Ignite servers will also be installed, and then from that Kafka, the data will be stored into Ignite, and then that can be utilized for dashboarding or any other purposes. So the Ignite supports really high frequency, high volume queries. That's where maybe Aditya, sorry, Abhishek one.
Yeah. So you got the data in the queue. Good. That is one thing. Now you need to understand queue is technically not infinite. I use the word infinite. You can actually make it infinite. You can always in behind the scene keep the latest data on the queue, like LFU. We all understand it's a least frequently used or recent frequency use model, and you can put the least frequently used model to the permanent storage. Next time while reading, you will have bit of latency because it will read it from there. So conceptually, that's how it works. But yeah, you have a queue growing, but somebody needs to read it, and that's where the another dimension of stack came up. When it comes to read it, why it is complicated, it's actually not complicated. The problem is how fast you want to read it and process it. You can read it by a normal Python script as well, or you can read it by a proper streaming engine like Apache Flink or Spark structured streaming, and those varies. How do you want? So if your data, you are getting a data, for example, in a minute you are getting quite a lot of mbs, like 100, 200, 500 mbs every 30 second. You are getting that kind of load, and you have so many events. Then you need a framework which is again a big data framework which can process them faster. It means you need no, sorry, you need distributed computing, where you could read parallelly, process, and find answer or insight faster. And that is where you need to decide, you really need a structured streaming Flink kind of a elephant frameworks which can process and do the things in distributed way. Because nowadays the trend is, I'm already using Spark. I've been told to write Spark code, structure streaming code. I just need to change the format in the frame, and everything is fine. It is not. It is not fine. Just by changing and get reading the streaming is one thing. Processing, saving, responding is a quite a lot of work. So when you are reading, you always need to understand how is your publisher, what is the speed, what is the latency, what is the size of data they are publishing. And when you consume by using technologies, you need to understand what kind of consumer you are looking for. Is it really a large scale? Then okay, Flink, structure, Spark streaming, whatever works, go ahead. The another thing in the dimension nowadays came up with, do you really need streaming? If you're, can't you just do real-time analytics? One of the very already I think Hitesh mentioned about Druid. There are another technology upon the Pino. So that way we have now a rush of technology which they say real-time analytics, where you can actually run SQL on top of the streaming and you can directly visualize them. So no in fancy complicated programming. You just do SQL kind of things or less coding, which reserve and publish things on the visual layer. So that is a somehow quite a bit of stack nowadays they are moving. I don't know the pros and cons of it. Because it is very business driven, but that is another kind of streaming era nowadays came, where where you use a systems like you can say SQL oriented or visual analytics oriented system, where you don't need programming or streaming engine, but this system which reads, consume, publish, and update your dashboard. So that is another dimension of streaming ecosystem. Any other points to add? Okay, so if there is no point, do we have in the streaming any particular questions to discuss? Like, is there any doubt, any question which in general we don't address? Like, because right now we just pick the basics on the basic ground of streaming, and I'm not going to start the question of Flink versus structured streaming. Those kind of questions we never get an answer to. But any, you can say, logical question we want to discuss now.
Yeah. So, subject, not a question, some query. So, whenever we are doing this Kafka streaming, so is there any time you have any idea like there we had a business logic apart from reading data from Kafka topic? Is there way we can build a logic dynamically to do something in Kafka, like apart from reading data, consumer and producing?
So,
Okay,
so
go ahead.
If you talk about the Kafka ecosystem, so Kafka ecosystem is basically two things. Okay? So Kafka, the server, and Kafka, the program. Okay. These are,
Okay.
so basically, the in the Kafka program, so basically you can have your normal producer and consumer programs, normal your Java program. Then you might have your KSQL or KSQL or KStream or Kafka Connect. So Kafka Connect is nothing but just a Java application. It's just really simple to deploy. That's why uh, they are just called as different terms. So, but basically, what they are just the programming framework on the top of Kafka, which basically utilize Kafka. Okay. So, whatever logic you want to write, so let's suppose if it is basic, if it's a basic thing like you want to filter something, uh, and then write it into one table, then you can use the k tables, and then from the k tables you can have another Kafka connect, which will write into whatever database you want to write. So that is a simple stuff you can do using the k table. And or case ecolocatable and Kafka Connect. The other way is, let's suppose you want to write some complex logic, and uh, and it can be written, and you want to process data one point at a time. Okay, so at that time the case stream comes into picture, and sometimes you can use Flink based on the uh, quantity of data that you are dealing with. Okay, and let's suppose you want to do processing in bulk. Okay, you have the bulk of results, and what you want to do is you basically want to aggregate the data and do some stuff. I'm just giving an example of aggregating and stuff because that is the most common thing that will happen in the bulk. So at that time you can use either Flink or Spark success streaming. Okay, so the problem with the Spark success streaming is it takes a micro batch, and the time for the micro batch is not even fixed. Okay, it varies. Your microbatch timing varies, and that sometimes causes an issue. Uh, yeah, so these are basically your options. So basically, if you how you want to process, based on that use case, you can choose what you want to use.
I would like.
Yeah, actually, sorry to interrupt. Actually, we have a real time example like where we are working currently on Kafka streaming.
Hmm.
So just to get to this forum, right? So real time problem. So
Hmm.
what is the problem here is we are trying to get the data like in the batch, and we are processing using Spark. Like we are
Hmm.
reading through topic consumer service. But the problem is the requirement is like we need to process that instead of batch. Suppose you have a batch of 10 records, we want to process the all the 10 records parallelly instead of batch. So for
Hmm.
that, we are trying to currently we are trying to read through consumer as a batch, and then we are writing our own services to take this 10 into separate
See,
parallel
it's a
orchestration.
simple thing, really simple thing. Okay, so based on the message, you are triggering some different tasks. Correct?
Yeah, yeah,
You're not processing that message. Correct? So in that scenario, that is not the work of Spark streaming. Okay? So Spark streaming is used to process that message itself, not the task it is providing. Okay. So basically, in that scenario, you need to use a consumer. So if you want to process that message itself, and do not and you do not want to trigger another action based on that message, okay, then the Spark is a good framework for you. Okay, but let's suppose if you want to, so I'll give a basic example. Okay, so let's suppose you get a message, and what you need to do is you basically need to trigger another job from it. Okay, you need to start another job from it. Let's suppose you want to start another Spark job based on that message. Okay, so in that scenario, Spark is not a good framework. Okay, and you will face so what will happen, your that micro batch will run for quite some time, and the other micro batches uh, will be backfilled in your queue, and once that thing is done, after that the next micro batch will be taken, and at after some time you'll face some sort of back pressure, and your spark jobs will start failing. uh, this thing you need to really consider when you are dealing with the team. Okay. So what you want to do, uh, that's how you choose your framework.
Good. So,
sure, sure. Thank you very much.
yeah. So along this topic of streaming, I would like to mention that nowadays streaming is no more about streaming jobs. So everybody is not Netflix, where you need to stream this answers and publish the things on the real time, because even they don't do it. They do it over CDNs. So there is another use cases of streaming. The first is nowadays is distributed queue, where you make queue as if your source of truth. So any event, any database, whatever the updates are coming, it is going to the queue. Means it is going to the Kafka queue or any queue. Kinesis queue, it doesn't matter. Why? Because then there should be a standard on publishing and consuming. So just imagine your database, you are not reading from databases. You have so many heterogeneous kind of data. Some are events, some are some consumer changes. It can be anything. So there are so many different schema of data, and if you put everything in a different topics of your Kafka. Then while reading, you can decide what you want to read. You just need to know that topic name, and anyone can read and anyone can publish. So that is called distributed queue based ecosystem. Nowadays it is coming to the picture, where everything is queue. You are publishing from one queue to another queue to another queue, so that you don't care who is consuming inside company. I mean, you do care, by the way. By infrastructure you can control who is reading from what, but I meant you need not to manage just databases. You need not to see what kind of query happening. It is a queue. You read and then you do whatever you want to do with that data. So that's another approach. And one more thing which is getting too much attention nowadays is CDC, change data capture. So when you make a change or any event happen, maybe you are pushing that to your database in Postgres. It's a consumer bought a product, so it went to the Postgres. But you may need to change the same thing in different databases. Like you have Elasticsearch for searching that particular consumer. You have another graph database to create a connection between, from a product you want to see the child, and your child nodes are nothing but your customers. So it means you have a three kind of database for same event. So how will you do that? You can't block the event, and you can't just say, okay, you stop, update, which is known as dual writes, which by the way some doesn't like. And that's where you have this kind of systems where from your SQL bin log and Kafka comes to the picture in between, all your database are getting refreshed with the new data. And that is another use case as a streaming nowadays is coming. So when you think about Kafka, don't just assume that if I need to use Flink or streaming or something, then only I need Kafka or a queue. Queue are nowadays getting used in a very different kind of usage, and these tools are one of them. uh, that is one of the point in the streaming. Anyone wants to add anything else?
You are right now are being used as for calling the API. Basically, uh, let's suppose uh, I want to call some AWS API. Okay, so I have a Kafka consumer, which is basically listening to a queue, and based on the details of whatever details I'm getting, an AWS service can be called, or some thing can be happen on the AWS. So that is where also the queues are running.